the C programming language. In this session, we are going to discuss about the following topics: the information about the C, what is exactly C, the structure of a C program, writing, compiling, and running a C program, the C's compilation model, how we can comments in the programming, data types and variables, scope in C, constant, literals, input, output, and operators. So these are the topics we are covering today to understand. First of all, about the C language, which is most of us we know. So it's a general purpose language. That means like it wasn't designed for specifically doing any, or creating any kind of software. It's a general purpose. We can use it for building any kind of software. It is procedural language actually, and there we write the procedures to implement the software. Imperative computer programming language. There imperative in the sense we tell system to exactly what to do. It was developed by in 1972 by Dennis and Ritchie at the Bell Telephone Laboratories to develop the Unix operating system. It is the most widely used computer language, as we know, and it's used for various implementations along with the other languages such as we have the Java and C++ also. So it's still in use even though we have the other languages existing, because each language has its own importance. So there are some features before, like every language we want to understand or anything, like we need to know about its features of it. So first, C basically it's a low-level language which is closely related to lower-level language such as the assembly language. So even like assembly language, after the assembly language C was created, because writing code in assembly language was quite difficult, as we have to use symbols there, like it's we call it as mnemonic codes. So after realizing the difficulty of writing program in the assembly language, this language was created, and hence we are able to do easier programming in the C language as compared to the assembly language. That is the low-level feature of the C language. It is portable. That is, we write the programs, whatever programs we write in the C language, they are called as portable, which means like you write the program in the Windows operating system. It can be run on the any other operating system also with slight or no modification at all. So our program is basically portable. So remember that the portability and platform independence are not same; they are different. So that is how it works. And it has the bit manipulation. That means we can write the programs in C language where we are able to manipulate the data in the memory at the lowest level called bit level. So as we know, like computers, understand better the bits. That is the electrical signals. That is they are represented in terms of zeros and ones, and we can manage the entire memory at the bit level. Then it has the higher level features, which is we call it as it's more user friendly as compared to previous languages. So such as previous languages we have like before C, which were created, such as the BCP, Pascal, and there are so many other programming languages. So they never provide such features where we are concerned about the managing data. So we have the high level features as well in the C language. High level and also means that it provides us with the abstraction to manage the data very efficiently. And it also supports the modular programming. Basically, modular programming comes from the idea that we are able to write the procedures in C language. So it's which is a software design technique that increases the extent to which software is composed of separate parts. So the software will be comprising of different small components which are called as modules here. Okay, so we are able to do modular programming in C language. So we can divide our software into different parts, and we can develop those parts and later on integrate them to make a whole system. And last one we have here is that's called efficient use of pointers. That means C is only the language which supports direct access to the memory, which is possible through the pointers. So when we have direct access to the memory, we are able to we are able to manipulate the data at the memory faster than as compared to the references, which is the opposite of the pointers. So these are the features what we have about the C language. Now let us take a look at the structure of a C program. You can see that I have different things written here line by line. You can notice here first I have written this we call it as hash include stdio.h, which is called as the preprocessor directive. Then after that I create global variables, which we will discuss what are the global variables later on. But we need to understand that after the preprocessor directive, we do something which is globally available to the entire program. And then we are writing the main function, which is usually called as the entry point of the C program. Basically in C and C++, both the languages, we have this entry point. Our application starts from this place only. So this is very important. This function has to exist in each and every C and C++ program. And within that, I mean the function, you can see I have written these statements. I have here two statements. One which is printf, which is again a function, predefined function, which is available inside this stdio.h header file, a preprocessor directive. And I'm trying to display a message through this printf. I think we can easily understand here that it's going to print this message onto the console when we run this program. And at the end of the program, because I have no more statements after that to be written, I'm just writing here return 0, which is indicating the end of our program itself. That is inside the main method. I have written this return 0. And so this is the entry point of our C program. After this, I still have statements. So I can do still more things below that main function. Here I can write again global variables or functions or declarations. So you can see when I talked here, I have the function, declaration, definition, or variable. Here also I have the same variable or function, declaration or definition, which is indicating that the C program is primarily consisting of only functions or variables. There are two things only in this C language. So we need to deal only with these two things in our entire development process, or else when we are even while learning also, either way. So that's about the structure of a C program. Let us go ahead with now how we can write, compile, and run a C program. So here we can see I'm using a software called, it's a free software, MinGW Developer Studio, which means Minimalist GNU C++ Studio. So we can download it over here from the internet free of cost. So we have to start the software, and we need to choose a new project where I can select here the Windows Win32 console application, providing the project name, and then click OK after that. Once we create the project, it has to contain files. In the file, I'm going to write the code, whether it is C or C++. You can see for either case, either C or C++, I can use the same choice here. That is choose here the C or C++ source file. So that we need to go for file and click on new and choose this option. Provide the name of the file, whatever you want to give here. Okay, and say OK after that. And it will open the file you can see in this area, main.c here, where I can write my code. I have taken the same code to here. You can see I've written hash include stdio.h preprocessor directive, and I have the main function here, and printf hello world and return 0, the same program which I described previously just some time back. So write this code here, and then go to the build option and click on build and execute. Alternatively, you can also press F8 to build and execute the program. So there are two steps actually for C and C++ program student. That is, we need to first build the program, then execute it. Okay, we will understand why we have to have these things, this compilation model. And once you run this, we'll see the output in a console. That is usually a command prompt in Windows. What we get like this kind of structure with black color area. You can see whatever message I was trying to display here, it's being shown, hello world, and then it'll show terminated with the return code 0. That this code 0, which is coming by this return 0 statement. So we need to remember that every C or C++ program must have the return type as integer, and it has to return this value at the end of the program to indicate that the program was successful. And then we have this prompt to continue the program. Once we press this, it will come back to the program itself. Now we'll understand the compilation model here of running C++ program. First of all, whatever program we are writing, whether it is C or C++, it may also have the header file, whatever header file we are using along with those programs. So that is being indicated here. You can see in the top we have the source code, which we call it as source code here. Just now the program which we wrote, we refer to as source code, inside which I'm writing the main and all other functions of my program. So whether it is C or C++, it's common for both. You can see that it has the extension .c for C language, .cpp for C++, and in either case we are going to use the header file, which is indicated by the .h. So all these files together, they have to be first processed. So that is the step 1. When we compile the C program, this is the first step which takes place here. We call it as preprocessor pre-processing part. Then after pre-processing is done, it'll basically your source code will be pre-processed, and it's going to use so many macros macros or the function calls or the declarations, all that will be substituted by the preprocessor. And next, your program will be compiled after this. So here we use this compiler called GCC or G++, which is open source compiler, which is going to compile this preprocessed program into a code called here assembly code. So it has the extension .s. Then further, by the assembler, it is compiled into the object code, that is object machine code. Remember that this is not exactly machine code, this is just called as object code, which is further required again one more step to convert into the executable code. So after the assembly code through the assembler, we are getting the object code, and then it is when we get the object code, we need to link it with the either static library or dynamic library. For that, we have a process called linking. So this linking happens here, and finally we get the executable machine code. This is the code which we run the when we open this file, the program runs, and we get the output. So these are the steps which are or forward, like when we write any program and run the program, all these things actually take place. Next, we have the comments. Any program, right? You must have noticed that our first program also I used these kind of symbols here, global variables, which I have mentioned some kind of symbol here, that is the /* and then something I'm writing here, then again I'm ending it with the star and the /. The same thing I'm doing even here also as well as here also. So basically, even here you can see I have mentioned that. These are all things which are ignored by the compiler, and they are used only for documenting your program. Documenting means you describe each line in the program what exactly it is doing, and they are not interpreted by your program. You will be just ignored. So it's only the reference of the program to understand your program. So say if you're writing a program and you want somebody else to understand it later, you can document it properly using this comment. So this is C style comment. Any C style comment can be written. It can be written on an individual line, or it can be written even after the statement at the end like this. Either way, we can use it. Just make sure you write /* and whatever you wish to write in between it, and then end with this star and //. So we can write either this way or this way, and we can describe our entire program, the purpose of the program, or the purpose of each statement, what exactly it is doing. So if I write a program today, say suppose I have written some lines of code, and after 2 years I want to refer it back to understand what exactly it did in this back. Now see, in that case, if you are not describing like this, it will be hard for you to understand. So we need to have this comments to get the proper description. So it's only for reference. So we call it as used for your program whatever we write. Now next we have every language has the data types and variables. We need to understand. You do any programming language you go for, you will have this data types and variables one or the other way. So basically, data types, they specify the kind of data what we are interested in storing the program. Like you're writing a program for storing a record of the student. So I can now see with respect to the student what all information, student's ID, the name of the student, the address of the student, and the date of birth. So these are the different types of data which you want to store in the memory of the program. Now to store each of these kinds of data, we need to have types of it, because we cannot store all of them in just like using a single type or in a single memory. So when they are stored in the memory, they are told the type of the data what we have here. So that way we have different types. So it is only indicating the kind of data that we want to store in the computer. First we have the basic type, then we have enumerated types and the void types and the derived types. So the basic types, they are called as arithmetic types. There are two types of it, integer and the floating point. So both are numeric actually. We will understand what these differences are. Enumerated types, they are types which are used for creating enumerated values, such as the name of days, name of months, all these set of values. When we are indicating, we use the enumerated types. Then we have the void type. Void type indicates that there is no type at all. That means not applicable. When there is no type, we call it as a void type, which cannot be indicated by any of the other types. Then we use void type there. Then I have the derived types. Now again in this we have pointer types, array types, structure types, union types, and the function types, which we'll go through all of them later. So what we need to understand is we have the four types here: the basic, enumerated, void, and the derived types. First we'll start with the basic types next after this. Under the basic types, I have, these are called as the as you saw here, I have first here called integer types, and after that the floating. Now we are understanding about the integer types here. So these are the types of integer, the storage in terms of memory, and the value what they can store, the largest and the smallest. For example, now the character is of actually 1 byte, that is 8-bit. That means when we try to store any single character such as A or B or C or 0 or whatever it is, it occupies 1 byte in the memory, and as well as it has the range. So that range is actually from minus 128 to 127 or 0 to 255, depending on the type of this. Again, further, this it can be either signed or unsigned. So based on that, it will have the different capacity. You can see I have this unsigned immediately below that given, which is again of 1 byte, but the value it can store is from 0 to 255. Basically, the character which we store inside the computer, like these alphabets, what we see on the keyboard, all these symbols, they are all stored as unsigned character. So that means like I have totally 256 characters if I'm counting on it. Then I have the signed character, which is again of 1 byte. Integer, which ranges from 2 to 4 bytes. Now again, you can see like it's given here like 2 or 4 bytes, which indicates that in some operating systems or the platform it is of 2 bytes and somewhere it is of 4 bytes. So it varies actually from platform to platform. So nobody can guarantee that integer is just of 2 bytes or 4 bytes. It depends on the compiler or the operating system that you're using. Based on that, the size will be varying here. And these are this is for 2 bytes of integer. The minimum number you can store is this one, and the largest is this one. So we have the minimum and the maximum for 2 bytes, and for 4 bytes I have the minimum and the maximum given here. In unsigned integer, again same size. The only thing it cannot is store the negative values, just like here we had. So we can't store negative values here. That means we can store more number of largest values. So it ranges from 0 to 65,535. And 4 bytes of integer, which is unsigned, will have more capacity still. I can store the largest number in this. Then I have the short integer. Basically, it's a short integer. That means whatever integer we discussed here, it is just half of it. So in case like it cannot be below 2, it will be always 2. Whether it is whatever platform we talk about, short integer is always fixed. It is of 2 bytes. So it is actually unsigned. It is actually signed. It has the negative value as well as the positive value. Unsigned short integer is again, we have the another version here, which is 0 to so much, 65,535. Then this one is the long integer. Long integer is always of 4 bytes. This is the range of the values it can store. Unsigned long, again same. The difference is only that here we can have negative, here we can have only positive numbers. So these are the different types of integer data type, I mean the subtypes of which we have discussed. And as you can see, the best way, like some places you must have noticed, like for example here these 2 places, you found that it's giving 2 or 4. As you know, we cannot write exactly what size it's going to occupy here. The best way to find out of any of these types you take, you want to find out how much memory they are occupying in any operating system or the platform. Okay, we have written a program to understand that. We can use this program. So in any language, I mean in any standard of C, whether it is with respect to the operating system or the platform, anywhere, when we have the C compiler and you want to know the size of the given data type, what you can do is I can just write this an operator called size of operator. In this program, you can notice I have this printf statement where I'm displaying this message: storage size for integer colon sign will be displayed as it is here. You can see the output is given here. Percentage D indicating that you're trying to display some integer value here, and after that go to the new line. So, and whatever this operator we are using, it's going to generate some output which is substituted in place of percentage D. That is 4 in our case we are getting here. Okay, so size of is an operator in C and C++ both actually. It takes a data type, what we discussed before, all these types, character, unsigned character, all these things. Okay, so we can take any of these types and just write in place of this integer and get the size of it printed by the system. And so I ran it on the Ubuntu this operating system. So I got the output as 4 here. If you run it in 16-bit OS, you will get different size there. So again, it varies. Okay, in my case, I've got here 4. So this is 4 means it's actually occupying 4 bytes. The size what it is given by this operator is always in terms of bytes actually. If I write here long, I'll get 4 again. If I write character, I'll get 1. So this operator can always give you the correct size of the data type what you are interested in knowing about. Continuing further with the floating point types now, again we have the types of float. So inter float we are having 3 types. You can see float is again of 4 byte, and this is the range of value which can be stored here. And let me tell you that float is something where I have the numbers such as 10.5 or 10.6. Okay, such numbers you can't store in integer. Yeah, need not to tell about this. We already know. So floating is something where I can have the decimal also when I want to store the number. So when we want to store such as the salary of an employee or the price of a product, where I have values after the decimal also, like 50.67 something like this. So when you want to store such kind of values, we use float for that. So float is 4 byte. It can contain 6 digits after the decimal place. If you want to store more digits after the decimal place, then you should use double here. It gives you more precision here. So for that, but the size also occupied is 8 byte here. We can store 15 decimal places after the dot. And long double, if you want still more precision, then I can use here long double, which is of 10 byte and 19 decimal places I have. Basically for scientific computing, because I want to have more precision, so I have this. I will need this types actually there. We don't use it for normal programming, but for scientific applications, actually we have to use this type. Continuing further now. Okay, the void type, what we discussed about that. Now see, you can basically I cannot use it like given these things this way. Like I have the float double and long double. They have got different meaning as compared with the previous discussion. They are all with respect to the pointer and the function. That's it. They are related to the other programming language constructs. So function returns as void. As we know that in C language we are only dealing with the functions. We use functions for creating the modules. So when we create functions, usually I can mention the return type of the function is void. So that is one of the type which is mentioned or is applicable for the function, and which indicates that that function is not returning any value. Like if you come back to our previous program, I have mentioned here integer as the type, one of the type for the main. There is a space here. That is actually indicating the type of the main function. The type what we are returning, the value what we are returning is 0 here. So that is the reason, because 0 is an integer, I mentioned the type as integer. In case if you don't know, if you want this function to return no value, I'm going to replace this int with void, which indicates that it doesn't return any value at all. So there I can use this first one. The function returns as void. So not only main, if I'm writing some other functions like my own functions, even there I can make use of this void. I can mention return type as void there. That means my function doesn't return any value. Function arguments as void. When you want to indicate that the function which you're calling, you're not passing any argument to it, I can mention void there. For example, rand random number, like I have this function here, which is taking no argument at all, so I'm indicating that with void. So this tells that clearly that you cannot pass any values to this function. We'll understand later on about this, what is this parameter calling, passing to a function later on. Third, I have the pointers to void. Pointers is one of the things because of which C, science very much, like we can directly deal with the memory in the C language. So there I have something called pointers. We use pointers for storing the address, the direct address of the memory, whatever is allocated for a program. So I have a type of the pointer, like where I can mention as void for it. You can see I have here void star, which is called as the generic pointer. So here I'm using one more place, the void, which indicates the type of the pointer. Basically, it's nothing. We'll understand even this later also when we deal with the pointers topic. But we use with pointer, we have to. So void type, you must have learned that we use it with the return type of the function, we use it as the argument of the function, and we use it with the pointer as well. Okay. So in case of pointer, there is a function called like this. Malloc function is there, which takes an argument, it returns some value. So there I'm making the use of void. I'm indicating the void is the return type of this. So this is the another one. So basically it's a void star, pointers to void. All right. Now next, coming to, once we have understood about these different types, what we have been through, these different for the integer, float, the types. Now we know like the scope of things. We write program, and the program takes input, or program stores some data in the memory. So when we want to store such data in the memory, we understood that we need to indicate the type of the data which we are storing in the memory, that we have just understood. Okay, but to store that data in the memory, because see, memory are usually numeric in nature. Like if I am storing my name somewhere in the memory, say the memory location is 100 and my address is in 2001. Okay, I cannot remember these names. I mean these memory by their addresses in my program. It's very hard for a programmer to remember the locations like this. Instead, we can give them some symbolic name. For example, in my telephone, in my phone book, in my phones, what I do, I store the number and I put the name before it. So when I want to identify that person, I can just, because I can remember that person by its name easily rather than searching for the number. Similarly, here in the memory, when you want to store, any data, we can give it a name in whatever memory we are storing it. So we create variables for that. So variables are, can be created to make it point to some memory, and I can refer to that memory easily by name. So when we create these variables in our program, okay, we need to understand the scope of variables, the first thing. Now we can create a variable inside a function. I mean, you must have noticed I have this C function here. I may have created, if I, 1 minute, I have to go back to this, yeah, here, the first one. As I told you that I can have the global variable or the function declaration either before the main. I can have them inside also here. I can have them here also, those variables. So when I declare them here or here or here, they get different meaning. That is basically called as a scope. I mean, when I declare it before the main, that is here, it has a different scope. When I declare them here, it has different scope. When I declare them here, again, it has a different scope. That's what we are talking about here, the scope of the variables. So that is inside a function or block. That is suppose if I'm creating a variable inside the main, so we call it as the local variable, which is locally inside the function. If I'm creating as the parameter to a function, that means when sometimes I write function when I pass the parameter to the function. So I can also declare them there. We'll see them later. So we have either them as the parameter to a function, or they can be inside a function, or they can be outside a function. Only three possibilities we have in C language. So 3 scopes we have. We'll understand them later. Here we have. Okay, so in this program you can see I have this header file and I have this main function. In this program I'm only using this local variable. First I'm giving the example for the local variable. So I'm writing I've written the comment, you can see properly, local variable declaration. I'm declaring totally 3 variables here. So this line declares 2 variables. You can remember that I'm using the type as integer because I want to store integer values such as 10, 20, 30. So I mentioned the data type as integer here for that. And after that, I have given 2 names, A, comma, B. I am separating 2 variables declaration by putting comma in between. That means it's going to allocate memory, 2 memories, and each memory will be given the name A and B respectively. Then again allocating memory, which is referred by the C variable. So these are all names to those memories. These names are given and their types are integer. Then I'm initializing these variables because see, you have just declared them here. They don't contain any value yet. So I'm initializing them here. So what I'm doing is whatever was created here, that memory, I'm initializing that memory with the value 10. Then I'm initializing the B memory with the value 20. And then you're adding the values of these 2 variables, whatever we have in these 2. It's going to add the value of A with the value of B and put into the C. And the same thing I'm going to display here. So I'm using this printf function to display the value of whatever I've got in the C after this statement. It's going to print here 30, as it's very clear, 10 plus 20 equal to 30. So printing the value of C, I am writing this printf statement. So for displaying the integer, whenever we want to display the value of an integer variable, I have to use %d to display the value. It's basically called as decimal. It's going to display the value. And then I have the return statement to indicate the end of my program. So this is about the local variable declaration, what we have done. Now about the global scope, the next one. See, you can notice that in this program, I have something outside the main, which is in the beginning. Before the main, I have, as usual, I have the preprocessor directive, and I have a comment here, global variable declaration, and I'm declaring a global variable G here. and then main function. Okay, and again I have two local variables, and then this time, as usual, I'm initializing. Just I have, you can see I have updated, like I have written all those things in single line. It's possible that I can write two statements in single line because each statement in C we terminate with semicolon. You can see that. So I have no problem in writing multiple statements in single line. I just split them for the sake of readability. So I'm initializing the local variables A and B with the value 10, and then I'm initializing G with this one. I mean, this global variable you're initializing with the value, again with the value of A added with the value of B, that is 30, will be put into this G. I have the comment here for this. Same way, like in the previous program we saw, we are displaying the value of G here, which is going to be 30. This program is only demonstrating that as compared to the last program, there we had all variables as local to the function. Now this time we have one as global here, which is created before the main. Okay, and there is one more thing, that when you declare a variable like outside of any functions like this, which we call it as global variable, this variable can be accessed by any function in my program. I may have some more functions. Inside those functions also you can access G, but these variables, which are because they are local, only declared inside the main, they can only be accessed here. You cannot access them outside. That is one truth about these two types, the global and the local. I have this another program here to show you, which is slightly again modified of the last one. We are not adding up any number here. I'm just trying to show that what happens if you create a global as well as local variable with the same name. Okay. So as usual in my if you refer to my last program, I have the same G created in my this program also here, which is containing the value 20. It's global declaration. Coming inside the main, I have a declaration which is containing the 10 here. So the question is, when we try to display this, it is ambiguous to understand, like what's going to show you. Okay, anyways, in the output it gives you 10 here, but we need to understand why it is giving me 10, because just technically we need to know about this, what exactly is happening. See, when we have already a global variable declared, and within any function like main, I may have any other function or even the main function, again I have declared a variable with the same name. Remember, these two are different memories, they are not same. This has a different memory, this has the different memory. The only difference is that this is global and this is the local. So when we, inside the function, when we try to access G, try to manipulate G in any way, it will give first priority for the local. If this doesn't exist, then it will refer to this one. So that is how it works. So because it's accessing the local copy, we get the output as 10 here when we try to display the value of G here. So we can have this kind of construct also, in case, in situation when we have the same name for the global and the local. What we need to understand is, like, it gives priority for the local, then that's the point. Now next we have the constants and literals. Okay, constants below, like we have this in mathematics as well, where the constant says any value which is fixed, we cannot change it. So we need constants even in programs also, where we want to create a memory which contain the fixed value, which should not be altered at all in my entire program. So they are called as the constants, and they contain the values also. Okay, we can create constant of any type what we have discussed before, like I can create a constant of integer type, number type, or it can be a floating point number type, or it can be a character, or it can be string. Different types we have. So they are just like your regular variables, except that the values what they store cannot be altered. Now, if you come back to this previous program, even though I'm initializing G with 10 and then I display the value, again, after that, here, I can come down and again alter the value G equal to say 30 and display it. That means, like, you can alter the value of G whenever you want here. That is just a variable. Okay, but when we come to the constants, we cannot alter them. Once we store the value, they cannot be changed. So they are like, you can initialize them only once. Only one time initialization happens, and nowhere after initializing anywhere at all, you cannot alter the value. So that is the thing about the constant. Now we'll see some constants examples. These are all different types of constants what we create in C language. So you can see I have these are all integer types. These are all floating point types. So integer is like 212. It's a legal constant, just a number. Like Constant means you are writing the value literally. You don't have any variable where you're storing it. So even this is also there. This indicates, the U indicates here unsigned, 215U, which is unsigned. This is a hexadecimal, and it's containing long at the end, a modifier. This is the octal, but this one is wrong because we are repeating the last symbol 2 times here. So see, the last symbol what we are putting, which indicates the like it's a modifier, which is here in this case it means it's unsigned. This means long. This means again unsigned, but you're writing this twice, so it doesn't make any meaning because you need to mention it only once to tell whether it is unsigned. That's it. You don't have to mention it twice. So that's what we have here. Now coming to we have more examples. Yeah, I have to tell you one thing here, that basically we are trying to create here octal number because it's starting from 0. But see, in octal system we cannot have the digit 8, so it becomes illegal to create this one like this. So this is illegal. Types of integer literals, these are the right ones we have. So 85 is decimal. This is the correct octal number because we don't have, remember that in octal we can have up to 7, not beyond that. This is the hexadecimal. Always hexadecimal number starts with 0x. This is the integer, this is the unsigned, this is the long. You can mention either capital or small, either way it will work. You don't have to think like I need to put only either small or capital. Either way it will take. UL means unsigned long. So these are all the different types. So you can see when I'm writing the, whether it is all these integer literals, I can mention modifiers at the end, or in some cases I can have this 0x to indicate the type of it. So it works like this. All these are the constants, and these are the examples of the floating point constants we have. So this is the floating point constant. You can see in floating point I can have the digits after the decimal. So this is like this we have. This is the long double. It takes like a long double. This is illegal here because when we say exponent, we need to mention the power of it, like here we have. So that is required. Even this doesn't have any exponent here. No decimal or exponent is given here. Even this is wrong because there is nothing before the decimal. So it has to be written in the proper format like this. 3 dots something exponential something, we can mention that. But here we have mentioned only the exponential, so it's wrong. It doesn't take like this. Continuing with further with the constant and literals, we have here the character. You can see the characters are just like single character. It can be any single character what you see in the keyboard. It can be your hash, at, exclamation mark, tilde, XC, ABCD. It can be anything. All these are called as the character literal. It is representing only a single character, remember, not like multiple characters, because when you say multiple characters it becomes a string. Okay, so you can see it takes either way, either it is a small case or the lower case you can specify. And you also must have noticed in my program, like I wrote somewhere, this /n. /n means when you want to display something new line in your screen, when you want to show the output in the new line, I'll say /n for that. When I want to have a space of tab before I display, I use /t for a tab. Question mark I use for when you want to literally display the question mark. When you want to literally display this double quotes, I need to use this / double quotes, and I have single quotes, and then I have this / character. So always all these characters, because see, they have got a special meaning when it comes to the programming in C. Like they always start with / and they have some meaning. So when you want to literally deal with them, you need to put / before them, which is called as the escape sequence. Okay, so we need to mention. So the meaning is given here. When you want to display / in the output, I cannot just write single / because when you say single / in some character, it gives some meaning. So I can tell the compiler that I want to display the / literally. So I can just write / before it. And for single character, then for double, single quotes, double quotes, question mark, and all these things we have. These are called as the character literals. And an example to understand /n and /t here. You can see in this program, I have a single printf statement with return 0 indicating the end of it. Just this line is what exactly going to execute in my program. I have written here hello, then /t, word, then /n, then /n again. See, these are all basically all escape sequence what I'm writing, /t, /n, /n. That means it's going to display the hello first in the output, nothing, just hello. /t is there is a space after that. You can see after the hello we have a space which is equivalent to pressing the tab key from the keyboard. Then the word after that, and there are two new lines. That means after this it comes to next line. Then again I have one more new line. So from there it will come to the next new line. When I display anything after this printf, it will start from here. It's like this. So we have 2/n for that. These are the escape sequences which I use in my program. Okay, now coming to the string literals. Usually string literals in C and C++ in most of the programming languages, you will notice that it's quoted inside the double quotes, like I have here. Hello dear, then hello. If I want to split across multiple lines the string literal, I can put just single backslash for it. So instead of if you suppose you're writing a long string literal, what you can do in that case, I can separate that length using this backslash here. So which means like you're writing something in the first line, then rest of the things in the next line. I can also write like this, hello so and so. So anything when you enclose it in double quotes, we call it as the string literal. You're literally writing the value here. Okay. Make use of those literals in our program now. All those what we have discussed. So we can see that I have this constant and using the preprocessor directive now. So we can create the constants in our program using either the constant keyword or something called preprocessor directive, which we will discuss here. Two uses of the, that is the preprocessor directive and the constant. So preprocessor directives, they will just look like how you include the header file here. I have this hash define length 10. Here it means this hash define is used for creating a constant in C language. So what we do is we write the hash define first, then we give a space and mention the name of the constant. Like the name of the constant, what I'm writing here is the length, and the value of this constant will be 10. That means just like a constant, wherever you write length in your program will be substituted with the 10. It's like this. Similarly, I have for the width also, which is 5. And I have one more constant called new line, which will be substituted with the /n. This is the these both are the integer constant, and this one is the character constant. Remember, we are writing inside the single quotes. Now see, in my main program, I have this area variable where I'm storing the the value after multiplying of length with the width. So now see what happens before your program is compiled. The preprocessor is going to search this length in your entire program, wherever you are using the length or width, and going to substitute that with the corresponding values, that is the 10 and 5. In this case, it's going to substitute length with the 10 and width with the 5. So it will become like 10 into 5, and that the product will be stored into the area. The same thing we're displaying here. Here I am displaying the new line, this one, which is the character. Now see, because I want to display a single character in the outputs, I use here %C for that. C means character, D means integer. So here it's going to display the value of area, which is 50, and this for new line. So the output is coming here, the 50 and the new line. New line cannot be seen here when you run the program. Like you can see the output of it, like your output goes to the next line. So that will be displayed here. So here this program tells about like how we can create constant in C language. I can use the hash define preprocessor directive for it. Hash define the constant name and the values for the constant. It can be of any type. You don't have to worry about the data type here. It's automatically, the compiler takes care of it, the entire thing. Okay, now this another one. Processor directive has defined way to create the constant. Now in this we are using the constant keyword. There is a keyword in the C called C and C++ both. There is a keyword called const constant, which lets you create the constant in the program. Now you can see this time I'm using this keyword constant. You can see as compared to the hash defined preprocessor directive, the constant requires the data type of what kind of constant you're creating. In that case, we don't need in case of preprocessor directive. So constant integer length equal to 10. So it's containing the value 10. I'm creating a constant. Remember that you cannot alter the value later on. If you try to do so, you will get the error. So it's only one time initialization. You must do it when you declare it. Constant integer width, which is containing the value 5, as same as new line. It was character, so I mentioned the character as the type here. Just like in the last program, I'm multiplying the value and storing in area, displaying it as well as the new line here, and I get the output. Just like the last program, the difference is only I'm using the constant keyword to create the constant here. All right. So next, that was about the variables and constants. Now we need to know about the input and output. How, because see, it is very important, like any programming language you start learning, you need to know like how I can take input to my program and display the output after processing it. So it's a very important thing we need to know. How we can take the input and output. In C language, we have two library functions, scanf and printf, which are used for dealing with the input or output in the program. And see, these two functions are defined inside the header file called stdio.h. We have already been including this file in our entire program. You must have noticed, like, it's the first statement what I write in my every program, because I'm using printf in one or the other way, right? In every program I have used it because it was defined inside this header file. So you need to include this header file. Any function when you want to use in your program, make sure that it has to exist in your program, and that existence we can bring by including the corresponding header file. So these two functions, the printf and the scanf from the stdio.h header file, it allows us to take the input and display the output. In this program, I'm just showing you like how we can add two numbers after taking input from the user, okay, and display the result. So my first statement inside the main function, I'm creating three variables. You can see that num1, num2, and the result. So that means you are allocating memory for holding three numbers of type integer. As of yet, they are empty. Remember, nothing they are storing. They may be containing some value which we don't know. But here we are allocating memory to hold three numbers, correct? And each memory will be given the names like num1, num2, and the result, the corresponding names. We are going to use those memories by these names. First, we see, because when we take input from the user, it's important that you have to communicate to the user what they have to actually provide the input. So that is the first thing we should do before we start taking the input. So I'm displaying a message to the user, printf enter value for num1. We need to display this message so that user can know, like, okay, I have to enter the value for the number. If you don't display this, what happens? The user will not come to know what input he has to give. So it's very important whenever we take input, we need to have a proper prompt for it. So I have this prompt for number1. Then I'm using this scanf function. See, this function takes the input from the keyboard basically, because the keyboard is the primary input device which is attached to our computer. So we take input through the keyboard by initiating this function. So we give a scanf, and see, the type of num1 is these variables are what basically integer. So to indicate this type, I'm writing this %d here. You can see inside the scanf function, we call it as the format or the control character. It has to be written inside the double quotes, and we need to tell this to the scanf function that the type of this variable which I'm taking input for is %d, which is an integer. We're indicating through this control character. Put a comma after that, and then display the right here ampersand in the variable name, and then close it. Every statement in C has to be terminated by the semicolon. You can notice that if you miss it, you will get the compilation error. Remember that. The same thing I'll do for the as I have done for the number1, I'll do it for the number2 also. Enter value for number2. Scanf, take the input. Once we have got the input for both the numbers, okay, first it will display this message, then it will wait for you to enter the value. So I need to enter the value there. Once I enter the value, say I entered 10, then it will prompt me the next one, enter value for num2. Then I need, after I have entered another value, say I entered here 20, it's going to add those two values what I entered here. So assume that if I had entered 10 and 20, it's going to be like 10 plus 20. It will sum up and store into the result. Then I will display that entire whatever I received here through this printf statement very nicely. So first of all, I'm saying go to the new line. Go to the new line and display the output there. So /n indicates go to the new line. Then display some value here. Then display a plus symbol. Then display some value here, which is of, see, %d always I'm using because I want to display the values which are of only integer types. So display this number here equal to, then display another value. So in place of first %d, it's going to display the value of num1. In place of second %d, it's going to display the value of num2. In place of the third one, it's going to display the result. So for our example, if I assume that I had entered 10 and 20, I'll get the output as 10 plus 20 equal to 30. That's what I'm going to get in the output. Okay, so that's how we can take input, in the program and process it. This is the processing part which I'm doing here. Here I'm taking the input, here I'm doing the processing, here I'm generating the output. That's how every program works. Okay, so that's it for this demo for today's. with respect to the C language. All right, bye. Hello everyone. So today this demonstration is for the object-oriented programming with C++, and we are covering the following topics in today's this demonstration. Actually, I'm going to take few. I have to, like C++, about the C++, the structure of C++ program, writing, compiling, and running, the compilation model, commits, data types, and all those things we have. So to short it, I'm going to take the key topics out of it. First of all, understanding about the C++. So it was created by the Wizard Institute at AT&T Bell Laboratories in the 1980s. And before this language, there was C language, like which is a procedural programming language. So it is just an extension of the C language. Like it has all the features of C language, plus it has some extra features. That is basically it has the classes. What we call it as the object-oriented programming features it has. Okay, so it is an incremental version of C. So it is, we can say that C++ is the superset of C. It contains all the things what we can do in the C as well as in itself. And just like C, even this is also, it's a compiled language. And most of the things we'll find common in C++ what we have in C language. So these are some important things about the C, like it is an object-oriented programming language, and it has the huge functional library. It's very flexible, and it has the versatility, and it is basically used for creating the huge software systems such as the operating system, compilers, and the editors and the databases. So the software industry was revolutionized after getting this language because it has the object orientation feature, and it is suitable for developing reusable components, reusable softwares, where we can cut down the development cost of the software. And just like C, even this is a machine independent language, and it is portable also. The main reason of creating the C++, even though we had the C, was that in C language we primarily focus on creating the modules and the functions, right, for writing the software. We need to create those components using the functions and then integrate it to create the entire software system. So what happens in C language, when I want to share the data among the different functions, we have to make it global. So when we make data global, actually we are exposing it out to the outside world. So anybody can alter the data, which may result for, in non-integrity of the data or non-consistency of data. So for that reason, when they found like the data is very important, it's very critical, they created the C++ where I have the facility to safeguard the data by the feature of encapsulation. As you can see, I'm going to discuss that. If you see this structure of a C++ program, we have this header file first, where I include the header file. Just like C language, even here we have the header file, and I have to include a namespace. This namespace we are including because we are going to use some functionalities in our program, like when we say the cout and the endl. These are the two things what we see, or the two tokens which are visible here. They both are defined inside this namespace, and this namespace is defined inside the IOStream header file. So that is how it is related, and we are using them in our program. In C++, we start program, by writing the class. So I have a simple class in C++, a class hello. So class is a keyword which is we use for creating the class. So we are safeguarding the data in this class by making it private. You can see that. That is the main reason, like for C++ to exist, to safeguard the data. So I created a variable with the name data1, which is inside the class, which is safe because I have made it private. By this label, you can notice I have the private here modifier. So this is just a simple class containing a variable and a function. The operation was the function name. So in C++, I can have a class or a kind of structure where I can put both the data and the operation together into a single unit. That is the class. Okay. We call this process as the encapsulation because we are encapsulating the data and the functionality both together into a single unit inside this class. The name of the class is the hello, and we need to terminate this class definition here. So in C++, we write program this way. We create the classes, we use them inside the main. Unlike the C language where I deal only with the functions, we don't have concern about the data. But here I have the concern about the data as well as the operation together. So whatever data we have, we need to have the predefined operations for that data, and both have to be united together into a single unit. So I do that using a class, which I cannot do it in C language. Okay, so there the data and the operation both are completely different. Just like C language, here also we have the entry point, because whether it is C or C++, we have to have the entry point. Most of the programming languages will have the entry point here where the program will start. So I have this entry point main here, return type as integer, main is the name of it. And here, whatever class I created, I am just creating a variable of that type. Usually we call it as the object. So I'm creating an object with the name h, just like your variables. I create the object by giving a type. Now here the type is a class, basically. Neither integer nor float nor any of those things, primitive types. I'm creating an object with a given class name. Once my object is created, I can call the function inside that class. Now, as per the definition, you can see that I have one function here, which is publicly exposed outside. This is not exposed outside, you can't access. This is the thing which you can expose. Anything you write after the public can be exposed outside, that is here. And whatever private you're creating cannot be exposed outside. So using this object, you're invoking an operation, you're calling a function. Okay, this is an operation you're invoking by putting the parenthesis and the semicolon at the end. That means when you say this one, when you say this statement, it's going to call this function. This function will do what? It will initialize this data with the value 10 and display the value here. So I'm getting the output as 10 here in this for this program. This is the structure for a C++ program, a simple program in the C++. Let us understand further. That is how we can create this program, compile it, and run it. And any C++ program, just like our as we do in C language, we need to use the software here. Minimalist GW Developer Studio. We can download it free from the internet, and we can install it. Create a new project in this studio, and make sure you choose here Win32 console application. Give the project name. After creating that, you need to create a new file inside it where I can write my C++ program. So you need to go for file and choose new. Make sure you have chosen C and C++ the source file here. Write the name of the source file, whatever you want. So I'm writing main.cpp. Say OK after that. And write your same program. Whatever program I discussed with you, I'm writing it here, the same program. And then save this program after that. And for running this program, go to the build menu, choose build and execute. Once you do this, it's going to run the program. If there are any errors, it will show you that below in this place. This is the output build part. In the build panel, it's going to show all the errors what you have in your program. If it is there are no errors, it's going to just run and show the output. So I'm getting the output as 10 here, as I discussed previously. When I call this function, it jumps here. It initializes the member with the value 10 and displays the value 10 in the output. And as usual, because the program returns 0, which indicates the exit code for your program, it is displaying your terminator with the result code as 0. Return code is 0. Some systems will say as exit code as 0. Then a prompt to continue your program. The compilation model for C and C++ both are same as we discussed. We have discussed this in C also. First we have the preprocessing, then we have the compilation, then we have the assembling, then we have the linking. So your source code, whether it is C or C++, will have the header file also along with. First the preprocessing takes place, which will substitute all the macros what we are creating here. Then it is compiled and converted into assembly code, which is assembled and converted into machine code, that is the object code. That object code is linked with the library, and then you get the final code which actually runs on your machine. That is how the compilation of the C++ goes on, just like your C language. As compared with, we have seen, or like in C language, we have this comment style. If you see this program structure, I have the same thing, iostream.h, including the namespace, and I'm writing this comment here. This is the C style comment. It allows me to write the comment in multiple lines also. Just make sure you start it here, and wherever you want to finish, put this star and /. Between these two things, you can write the comments across different lines, across multiple lines. This is the C++ style comment. It's introduced in C++. You can write comment in just single line. You cannot write in multiple lines. You have to write here 2 / and write the comment here. This is the main function. I declared a variable here, num1. This is the variable declaration. I'm initializing the variable with the value 10. Then again writing the comment here, describing the program, adding the value, again initializing it, adding the values, and doing the steps. So basically this program is just to make you understand like how we can write comments in C++, apart from what we have in C. This is the C style, this is the C++ style. So across your program, we have written the comments to give description about the program. So we use it for documentation purpose. That is for like you're writing a program now you want to refer the program, after some time, like in a year or 6 months or 7 months, like that. So when you want to understand what you wrote before, you need to make use of comments to properly describe each line so that you can understand it later. It's for the documentation purpose. Data types and variables in C++, as data types indicate the kind of data that we want to store in the memory of the program. It is not any different than your C language. Actually, we have the similar things. So data types such as you want to store a number, you want to store your name, you want to store the character or the address, date of birth. These are all different categories of data we want to store in the memory of the system. So when you want to store such data, you need to tell the system that what kind of data you are interested in storing or you're storing. So to tell these types, we use the data types which are available to me through the programming language itself. They are character, wide character, integer, floating point, double, floating point, boolean. In C++, we have boolean also as compared to C, and these are the different types. So we need to tell the type of data by these types when you are storing them in the memory. Okay, we have these are all built-in types we have in C++. These are all types actually, which is and for indicating these types in my program, I use these keywords. Like when I want to store the boolean data, which is either 0 or 1, either it's true or false. So we use bool keyword for that. For character, I use char. For integer, is just int. For floating point, it is float. For double floating point, it's double. And valueless, that is no type, without any type. When I want to indicate there is no type, I use void. And for wide character, I use wcat. So all these types can be applied the modifiers also, which are given here, like signed, which means like it's storing. Signed indicates that when it's applicable to the number, especially, we say it can store either negative or not. So we use signed for that. Signed means it can store negative also as well as positive. But when I say unsigned, it can store only positive numbers. Short is a modifier. Long is another modifier. So these modifiers can be applied to all these given types, predefined types. Now this list tells you about the entire thing, like after applying the modifier also. Just like we have it in C, we have this character type of 1 byte. So this indicates the type of all the possible types of data type in C++, along with the size it occupies in the memory and the range of values which it can store. As you can see, for character I have 1 byte, the range of characters it can store. Unsigned character is again of 1 byte. This is the range of it. Signed character 1 byte, integer 4 bytes, unsigned integer 4 bytes. Signed is a 4 bytes, so you can just see that the entire list. Okay, so these are the different possible types which we can have in C++. And as usual, it's very important, like when you're writing a program in C or C++, you need to check the type. I mean how much memory these types are going to occupy, because it differs from platform to platform. So to do that, I can use an operator called size of operator. See, it looks like a function. Don't mistake it for a function. It's not a function, it's an operator. Okay, so this is C++ way of displaying the output onto the console. I use the cout. This is called as the insertion operator. The two symbols, two left shiver signs. Then this is the message which you are literally displaying, and then again left shiver signs, two left shiver signs. That means after displaying size of character, it's going to display actually the value written by this operator. So size of character, it's going to return the value 1, which means 1 byte, and then a new line character after that. That means the next output what we will display will come after this line, which is coming from this endl. This is equivalent to writing /n what we have in C. So whether you write /n or you write endl, either way it is same. The only difference is here it is called as manipulator, there it is called as a character, new line character. So similarly, you can display the size of all the types. I have for character, integer, short integer, long integer, float, double, and w character. So and then I have the written 0 at the end of the program to indicate that my program is ending. So we can display it's very important. Whenever you don't assume yourself and write just 2 or 4 to say that the size of data type is so much, always display it through the program by writing the program. Use this operator in your program to retrieve the size of the corresponding data types and use it in your program. This is the right way of dealing with the data types. The scopes in C++, it has the similar scope as we dealt with the we have dealt already in the C language. That is, we can declare variables inside the function. We can declare it outside the function. We can declare it as the passing the parameter also. Three ways we have. We are going to understand the first way here, the local variable. You can see a preprocessor directive IO stream. Then we have this std namespace because we are using this cout, which is defined inside this namespace. Our main function, the entry point of the program. I'm creating the local variables. This is the command I'm writing to describe that, to tell the meaning of these two lines what I have written here. That is, I'm creating the local variable declaration. I declare two variables, separating them with comma, terminated with semicolon. Then I have this C, another variable declared. I can declare this C also here, but it's our choice as and when you want to do. These variables which I have declared here, it's only available within this function, this main function. You cannot access these variables from outside the function, that is from anywhere else. It's only accessible within this itself. And you are initializing all these three variables here. I'm initializing A with 10, B with 20, C equal to A plus B. That is, whatever we initialize for A and B here will be added together and put into the C, and then the variable will be displayed. That is 30 here, what we see in the output. Then indicating the end of the program. Here we use cout object to display the value of C. So this is the local variable thing what we have done here. It's only within the function and you cannot access them outside the function. This is the global variable declaration. Similar to C language, we have this variable declared globally. You can see that that is before the main. Outside of any function, when you declare a variable, it's called as the global variable, and we can access them from within any function. So from main function, I'm creating two variables again, initializing them with the values, and their addition I'm storing into the G. Okay, so you're taking the values of the local variables, adding them together and putting into the global variable, that is G, and then you're displaying it. So we'll get the output as 10 plus 20 as 30 here. Very simple, very easy to understand. The only thing what we wanted to know here is the global. So we create the variable before outside the function, that becomes a global. Like I have G here, and it can be accessed from within the function also. It can be manipulated by any function, whatever you have in your program.